Well, I'm joined now by Professor Robin Shattock from the Department of Infectious Diseases at Imperial College here in London. Thank you for joining us. Now, lots of talk about how this can be contained, but let's talk about a cure because you've been working on a potential vaccine. Tell us more about that.
Yes, so one of the really good news parts of the scientific endeavors in this space is that the scientists in Wuhan shared the genetic sequence of this virus really very quickly, and that's allowed people around the world to access that and start designing vaccines. And we're one of a number of groups globally that are using that information to put into a vaccine candidate as quickly as possible. We're working in the laboratory, and we'll have it in animal models by the middle of next month.
That's quite a speed. I imagine vaccines don't come about this quickly usually.
No, I mean, if you contrast it with the Ebola vaccine that we've heard a lot about recently, that took 10 years to develop before it even went into human studies. And then it took 2 years to test it within humans. We've kind of changed the technology, and other groups as well, to use genetic sequence to engineer a vaccine so it can be injected into your muscle and express just a part of the virus to induce an immune response. We could accelerate that into human studies if we're called upon to do that within a matter of months.
You touched upon it there, but in layman's terms, how do you go about creating a vaccine? I mean, what are the steps that you need to take?
Right, so there are several different approaches to developing a vaccine. The approach that we are developing, because it's the fastest approach, is to use the genetic code that encodes a proportion of the vaccine, what we call the envelope spike. And that's the part of the virus that antibodies latch onto and prevent it from infecting cells. Now, there are other more complex ways of making vaccines that might give you a longer-term immune response, and people are working on those as well. The real factor here is time. It takes time to do this. We can get to humans within a matter of months, but that's just to check for safety and immunogenicity. Start testing whether it works will probably not happen until this coming winter, and then it may be globally available.
Okay, so the key question there is, what if the outbreak is controlled by then?
So if it's controlled by then, that's good news.
Course,
I mean,
yeah.
Essentially, we hope that it will be controlled by the steps that the Chinese government is taking in place, and that will be good news. But we also need contingency in case it's not controlled and it becomes a global pandemic.